Okay, see this soda? I've been typing so much, it's 4:30. The soda has not been finished yet. Yeah. 4:30 p.m. Last time you got to see the funky 1950s stove that came with the original house that my children will not let us get, or our children will not let us get rid of. If anybody wants a vintage stove, let me know and I can go get the stove I want. Be that as it may. We talked about valence electrons and how to represent them. So before getting into rules for drawing Lewis dot structures for elements, I thought it might be a good idea to give you some phrases so that when the phrases pop up or the definitions pop up in the rules for Lewis dot structure, you'll know what we're talking about. So last time we saw that Lewis dot structures had any element X and you could have up to 8 electrons around it. That is most of the time. Something that has 8 electrons around it is obeying what's called the octet rule. Okay, the octet rule means that elements are most stable when surrounded by 8 electrons. This is except hydrogen. Hydrogen never wants more than 2 electrons, but we'll get back to that. We're going back to this 8 electrons, stability of a noble gas configuration. We'll get electrons any way we can to grab 8. Okay, whether you beg, borrow, or steal them. So that's the octet rule, and that gets mentioned a lot. If we draw just a generic element, or we can draw water. Let's draw the Lewis dot structure for water with no rules. Just let's look at it and define a couple of things here. The electrons in the middle are called bonding electrons. The purpose of the bonding electrons is to hold hydrogen and oxygen and this hydrogen and this oxygen together. Because of the number of valence electrons 2 hydrogens and an oxygen have, we've got a couple more electrons around the outside, and these 2, top and bottom, are called lone pair electrons. And if we want to count up electrons around an element, bonding electrons, these guys, are going to count twice. So hydrogen has 2 electrons by it. This hydrogen has 2 electrons by it. And this oxygen has 2, 4, 6, 8 electrons by it. So the octet rule has been met for oxygen. So you know what the octet rule is. You hopefully know what bonding electrons are, and you hopefully know what lone pair electrons are. Okay, couple of other things. You can have 3 kinds of bonds. Not as in polar, covalent, nonpolar, covalent, and ionic, but as in single, double, and triple bonds. A single bond is simply 1 pair of electrons in between 2 atoms. A double bond is 2 pairs of electrons between a single atom, and a triple bond, which is the heaviest, shortest, strongest bond you can have, is 3 pairs of electrons between 2 atoms. If we draw these as lines instead of pairs of electrons, we would do X with a single line, 2 X's with 2 lines, and then these lines are parallel to each other. They're not up and down, but they are horizontal, even though the pairs of electrons are vertical. So a single bond is 1 pair of electrons, a double bond is 2, and a triple bond is 3. I guess the last thing we can maybe do right now is talk about resonance structures and get that out of the way. This is all just you're going to have to look at this video again, but resonance structures. I have found the easiest way to think about resonance structures is you have a double bond that can move. And that double bond has to move to what we call equivalent positions. Okay, so let's do fictitious molecule X2A. And when I draw the Lewis dot structure for X2A, it looks like this. Now, you guys don't know how to draw these yet, but let's count things up. These two sets of electrons are lone pairs. That's a lone pair, lone pair, lone pair, lone pair. Bonding pair, a double bond. This X has 2, 4, 6, 8 electrons around it. Bonding pairs count for both elements count for the element that is in the middle of them. So A has 2, 4, 6, 8 electrons around it. And this end oxygen has 2, 4, 6, 8 electrons around that. So this particular made-up element satisfies the octet rule. But why did I choose this X to make the double bond with A? I didn't have to. I could have done this. I could have done X, putting 3 lone pairs around it, and A with its lone pair on top. X, A. Okay, and here we have the double bond here. Still 8 electrons, 2, 4, 6, 8 around X, 2, 4, 6, 8 around around A, and 2, 4, 6, 8 around this X. All I've done is I've moved the double bond from this spot to this spot. So to have a resonance structure, you have to have an element which is capable of making a double bond that leaves out hydrogen, and you have to be able to move the double bond to an equivalent position. Here it's between X and A. Here it's between X and A. They're just in different places in the molecule. So those are the terms you need before we can discuss rules for drawing Lewis dot structures. See you in a bit.